Welcome to this video where we're going to discuss the Array.fold method in F#. I'm going to structure this a little bit different from the previous videos in that we'll start by looking at C# code for the equivalent implementation, because I think a lot of you are familiar with C# code and that would make it easier to understand what the F# code does in this particular case. So the use case that we're going to consider is we're trying to sum up all the even elements of an array. And the way we would implement that normally in C# is with a for loop. So we would simply iterate over the array, have some sort of state variable that keeps track of the cumulative sum at the given state, and then we would print the result in the end. So I'm going to copy over some code here, and we're going to look at how we would implement this in C#. So first I'm just going to print that this is the C# code, and then we'll define the array, and we would initialize an array like so. What I did here is I have an array starting at 1, ranging to 30, and equally spaced by 3. And in C# you can initialize that like this, just simply providing the values. Then we'll give it a state variable, and this is going to keep track of what value we have as we loop over this array and start summing up values. And this value variable is going to keep track of the current value that we're at. So the current spot in the array that we're at when we're looping over it is going to be contained within this. So we'll do a looping over these values, and the way we would do that in C# is simply a for loop like this. So I guess you're familiar with that. We would initialize some local variable that just counts the index that we're currently on, and we'll start with having that at 0. We'll loop until we reach the length of the array, and we'll iterate this iterator with a value of 1 each time. Okay, so no surprises there. And then within here, we would do a check whether or not the value that we're considering is even or not. And the way we would do that is first we would just set this value. So the value variable here that we said should keep track of the current value, we'll just set that to be where the array is pointing to. And then in here, we'll say if value modulus 2 is 0, so if it's even, then we'll implement some logic. And if that's not the case, then we'll implement some other logic. And what we'll do for both of these is if it's even, then we'll print to the console that this is even, and we'll say that the new state is going to be the old state that we had. So we start with a value of 0, and then we add the current value that we're at, so the current element in the array, to that state. So we make this, or we iterate the state as we traverse this array and make it larger whenever we have even values. And if that's not the case, so in the else statement, we'll print the following instead. So we'll just say that this is not an even value, so it's odd, and the new state is going to be what the state was before. Okay, so simple enough, and if I save this code, we should be able to execute it as well. So let me just run this. And what we're going to do then is we're going to traverse this array. When we have a value of 1, for example, we're not going to sum that up because it's an odd value, but 4, for example, and 10 and 16, these are all going to be summed up to cumulative total in the end. So we're going to let that finish, and while it's finishing, let's start actually with the equivalent F# code. So first of all, let's just initialize the same array that we had in the C# code, and let me just print that in here. Already in F# code, we can see that this is a bit more compact. So I define a value array, and I can just say 1 to 30 with a step size of 3 here, and that's going to initialize the same array that we had in C#. And we can see now, if we go back to the C# code, that it's finished. So the first element we get here says that the value is odd and the new state is 0. That means when we're looking at the first element here, we're saying that it's odd, and the new state is going to be 0 because we had a state of 0, and we don't add anything because this value is odd. Then we go to the next value, which is 4, and we notice that this is an even number, and the new state therefore becomes what the old state was, namely 0 plus 4. And so the new state is 4, and you get the idea. We do this for all the elements in the array, and in the end we end up with a value of 80. Now, in the F# code, we initialize this array now. That is the same array that we used in the C# code, but a bit more compact. And what we're going to do is we're going to create a function, a folder function, that is going to be applied to all the different elements of the array. And then we're going to use a built-in array method called Array.fold to apply this folder to the array. So let me define the folder, and we're going to see what that means as we go along. So let folder, and this one is going to take 2 parameters. It's going to take a state and a value. And I named these state and value for a reason. So these correspond to the state and value that we had in the C# code here. So the state represents the variable that we're cumulatively summing toward, and the value is the current value in the array. And it's going to be the same thing in the F# code here. So state will persist across iterations and sort of get accumulated over time, and the value will point to the current value, and we'll use that in the computation. So this function is then going to tell us what we do given the state and the value. And here we're going to put an if statement. So if the value over 2 is 0 here, so if it's an even number, just like we did before, then we're going to have some logic, and this logic specifically we're going to print and iterate the value. So let me just paste that in like so. So we're going to print that the value is even, and the new state is going to be the old state plus the value. So you can see that this is exactly the same kind of logic that we used in the C# code before. We said that if the value is even here, we print that it's even, and then here we updated the state. The difference here is instead of updating the state variable, because remember, variables in F# are generally immutable, what we're going to do is we're going to return a value instead. And the value that we return is going to be state plus value. Okay. And then for the other case, so then we'll have else here. And in there, we're going to do similar to what we did in the C# code, or rather the equivalent to what we did in the C# code, which would be the following. So we print that this value is odd, and we say that the new state is simply what the state was when we apply the function, and we return the state like that. Okay, so how do we actually apply this now? And this is where F# is kind of very clean in a way. So you would let the result, if we call it that, be Array.fold. So this is the function that we're going to use. And you can see in the signature of this function that we have a folder first. That's the function that we apply to each element. So that's the function that we just defined. The second element is going to be a state, and that needs to be the initial state first. And in C#, our initial state was 0 because we initialized the state variable to be 0, and then we summed that up as we went across. So we're going to do the same thing here in F#. And then finally, we provide the array that we want to sum over or iterate over. So folder, we have this exact function defined under the exact same name. So we provide that first. Then we're going to provide the initial state, and we're going to say that this is 0 in this case. You could initialize that to another variable if you want, but since we're starting to sum from 0, we're going to leave the state to be 0. And then array is going to be the final argument that we provide. And so that's how you apply it. Now, what F# is going to do is going to take this folder function that we defined. It's going to apply it to each element of this array and sum those values up. And it's going to start with an initial state of 0. And what we can simply do in the end then is we print what the value is here. So we'll just do like this and just print the result. Okay, and if I save this, I'm going to be able to execute, and we can just compare what the output of this evaluation is going to be compared to that of the C# code that we wrote just before. So we can see in the C# code that we had here that we started with a value of 0, we got 4, and then we skipped the next value because it was odd, and so forth all the way up until 80. And for the F# code, which now finished, we can see that we do the same thing. So we start here with an initial state of 0. We print intermittent statements here, and that comes from the folder function where we sort of defined these or included these print statements as it evaluates. So we can see that it loops over the array also from left to right, so as it's defined in the same way that we did with the regular loop in C#. And for each one, or for each state or value that we encounter here, we update the state to reflect this cumulative sum that we have. And in the end, we end up with 80, which is the same result. So this is how you apply it in F#, and it becomes particularly neat because you can link different methods like this together in a very compact way. So you can define these folder functions in sort of a common library or somewhere in your files, in the files that you write, and then as you actually apply these, you can make the code very compact, and you can nest different kinds of applications together. So this is a different way of writing code, and that's generally the way we do it in F#. And it allows us to write very compact code and very concise code. So I hope you enjoyed this video. That's sort of a comparison between the Array.fold method in F# and just how we would do the equivalent statement with for loops in C#. Please check out the next video, and yeah, see you there.